If you can do synthetic division, it's not. If you're decent at synthetic division, it's not bad. All right. Okay, so we're going to talk about zeros of polynomials today, and where we were working at before in section 5.5, they gave us one of the zeros to start off with, and what that meant was that if you divided by that number with synthetic division, the remainder would be what? 0. And that's what we're using that idea to help us break a polynomial down further and find all of the zeros for that polynomial. Okay, so the first thing we want to talk about is the possible rational zeros. What's a rational number? Whole number would be example of a rational number. What other kinds of numbers are rational? Yeah, but what specific what's the special thing about being a rational number? It's in a ratio, and ratios are normally written as fractions. Okay, rational numbers are numbers that can be written as fractions. Okay, so when we're talking about the possible rational zeros, so we're talking about all the possible zeros of a polynomial that could be written as a fraction. So these are the ones that don't have like a square root of 2 or something like that involved with them. It's whole numbers, it's fractions, it's nice, good numbers that are easy to do synthetic division with. Okay, so when we're looking at possible rational zeros, we're going to look at this thing called P over Q. The P that's on top, it stands for the factors of the constant. And we'll get a polynomial here. The first example, we'll get a polynomial. We'll see what that is. And then the Q stands for the factors of the leading coefficient. All that means is the number in front of the highest exponent on the variable. Okay, so when we're looking at a polynomial, example A, we want to list the possible rational zeros. Okay, so if we're going to list the possible rational zeros, let's look at this polynomial. F of x is equal to x to the third power plus 2x squared minus 11x plus 12. Okay, now what's in front of x cubed? Say what number? 1. There's nothing there. It's a 1. Okay. That 12 on the end is our P. Q is 1. All right. So when we look at the possible rational zeros, P over Q, it's like 12 over 1. But we got to think, what are the factors of 12? What all numbers go into 12 evenly? 1 does, 2, 3, 4, 6, and then 12 goes into it as well, right? And then what are the factors of 1? Just 1, right? Now here's the thing. It's plus or minus in front of all those. Now what we do is we look at those as ratios. Jordan said a rational number is a ratio. We look at that as ratios. Since there's only one factor in the denominator, that means the only possible zeros for this polynomial are 1 divided by 1, 2 divided by 1, 3 divided by 1, 4, 6, and 12, all divided by 1. So the possible rational zeros, and I'm going to write it like this, plus or minus, and then a little curly brace to say it's positive or negative 1, positive and negative 2, 3, 4, 6, or 12. Okay. Those are the only possible rational zeros for that particular polynomial. Now, will all of them work? Not very likely. How many answers should this polynomial even have? 3. Why? The cube, the highest exponent is 3. So the most that we could have would be 3. Now, that doesn't necessarily mean that all 3 of them come from this list. It's very likely that one of them does, at least. Okay, and we'll get into actually doing that in just a little bit. But I want us to get used to this P over Q list, because that takes us from having to guess all the numbers in the world down to this one. It took us down to a list of 6 numbers, technically 12 because the positive and negative side, instead of from negative infinity to positive infinity. So that cuts it down a lot to a very few set of numbers. Okay, so we're going to work on getting that P over Q list, and then we're going to say, okay, what can I do with that? All right, so let's look at this polynomial. G of x is equal to 4x to the 4th minus x to the 3rd minus 3x squared plus 9x minus 10. Okay, so if we're looking at that polynomial and we're looking for our P over Q, what part goes on top? What's the P and what's the Q? Yeah, P is 10, Q is 4. Doesn't necessarily matter that it's positive or negative when we're talking about P over Q, because they're going to have that plus or minus in front of everything anyway. So now we think, what are the factors of 10? 1, 2, 5, 10. Then on the bottom now we got a 4 instead of a 1. So we got a little bit more action here. What are the factors of 4? 1, 2, and 4. Okay. So then we're going to take that and we're going to do the ratios. 1 over 1, 2 over 1, 5 over 1, 10 over 1. That takes care of the 1. And then we're going to do 1 over 2, 2 over 2, 5 over 2, 10 over 2. And then we'll do 1 over 4, 2 over 4, 5 over 4, 10 over 4. And reduce all those ratios. And don't write any repeats. Okay, so let's start with the 1. That gets us plus or minus 1, 2, 5, and 10. That's everybody that goes with the 1. Now everybody that goes with the 2, 1 over 2, that's a ratio. We haven't gotten 1/2 written down yet. 2 over 2, what's that reduced to be? I've already gotten that. I don't have to write that again. Okay, so 2 divided by 2 is 1, so we've already got a 1 in our list. Then we have 5 over 2. If we got 5 over 2 in our list, that doesn't reduce, so I know I've got a fraction, 5 over 2 there. And then 10 over 2 reduces to be 5, and I've already got a 5 in the list, so I don't have to write 1 for 10 over 2. Next one is divide everything by 4. So the first piece, 1 over 4. Do we have a 1/4 yet? Nope, so it's got to be in the list. And then we're going to have 2 over 4, which reduces to be 1/2, and I've already got a 1/2, so I don't have to write it again. 5 over 4, that doesn't reduce, and I know I don't have a 5 over 4. I got to write him down. And then 10 over 4 reduces to be 5 over 2, and I've already gotten that one. Okay, so I have now cut down the possible rational zeros for this polynomial from every number in the world to a set of 16 numbers that it possibly could be. Okay. All right. P over Q. Now, there are questions that are going to be asked. I know on the end of the course, they're going to ask you to list the possible rational zeros of a polynomial. And it's just making that list and doing nothing else with it. In college algebra, that's one of the things that we work on, is just writing the list of possible rational zeros. That doesn't mean we're not going to do anything with it. We're about to, the next several examples, we're going to do something with that list. Okay, and see what we can do to get there. All right, so let's use the list of possible rational zeros to factor / solve the polynomial. or for the polynomial zeros. Okay, so we're going to find all of the zeros. So if it starts with an x to the third power, we should find how many? 3. If it starts with x to the fourth power, we're going to find 4. That sort of thing. That's what we're doing here. Okay, so let's take this polynomial. Example C, f of x is equal to x to the third power minus 8x squared plus 11x plus 20. Okay, we want to use our P over Q list. So which one, the factors goes on top? 20. And then what goes on the bottom? 1. So that's a pretty easy list, right? It's only going to be the factors of 20. What are the factors of 20? And 20, right? So we've cut that down to 12 possible numbers. Positive 1, 2, 4, 5, 10, and 20, or negative 1, 2, 4, 5, 10, or 20. That's our possible rational zeros. Now, what we want to do next is do some synthetic division with one of those numbers and see if it gets us a 0 for this polynomial. Now, here's where your graphing calculator comes in. I mentioned yesterday you wanted to have your graphing calculator today. If you've got it, great. If you don't, I've got a couple of spares that we can deal with. But so we need our graphing calculator for this. What we're going to do is we're going to do synthetic division with that polynomial, but I got to know what to put on that shelf. And I don't want to, when I learned this in high school, we didn't have the graphing calculators. They existed at that time, but they were far too expensive for us to be able to have them here in Nashville. So we had to try every one of those, like by hand with synthetic division. And that ain't cool. I mean, so this is where this is where the calculator comes in handy. So I'm going to set up my synthetic division, and then I'm going to use my calculator to help me find one of those that works. All right. So with my graphing calculator, I'm going to type that polynomial into y equals. So I'm going to hit y equals, and then clear out anything that you've got in there. And then I'm going to type in that polynomial, x to the third power. So x, caret symbol 3, minus. All right. From the original home screen, like regular calculator screen, hit y equals, top left. Top left most button. Yeah, it says stat plot on the top. Like marked out or worn off. Yeah, that's possible. All right, so the top left one is y equals. All right, and then I'm going to type in that polynomial. So x raised to the third power. I hit the caret symbol, little house top looking symbol, and then hit a 3. Now, depending on how you're calculating. All right, yeah, you got to press to the right arrow. You have to press the right arrow key to get out of there. I hit that as well, and you just didn't see it, I guess. So the right arrow key after you get the third, minus 8 x squared. To get the third power, you're going to hit the caret symbol, just right above the division symbol, and then a 3. Then the right arrow key. And then x is right there beside alpha, right here, beside the green button. Can you just hit alpha and then hit the green? You don't have to hit alpha at all. Yeah, don't you? Why would you hit 2 buttons instead of just one? Well, so in the future, you just hit that 1. That's what you want to do. It'll work doing it with the alpha and then the x, and then plus 11x, and then plus 20. Okay. Now we could graph this on the calculator, and that's what I want to do. Is I want to hit graph. And if you hit graph, hit zoom 6, so everybody's window will be the same. Zoom the button in the very center of the top row, and then number 6. So you got.
You get graph?
And then hit
I'm
graph.
confused.
Oh, you got the
Yeah, mine's just a straight line on the other side of it. Hit zoom 6.
Yeah, now you can see. Hit zoom 6 and see if that fixes it. Does it? If not,
Click
hit
zoom
zoom.
and then 6.
No, you click the zoom and you have to scroll down behind you.
Or you can.
Oh.
Don't have to scroll down. You can hit. You can actually type it. Is it not? I don't know. It may have been just scrolling my graph.
Who is that?
It's really funny about
Ah, yeah, you got my name.
Oh, yeah.
That makes all
Did you get it all?
Oh, yeah, very subtle. Very subtle. There you go. You got it right there. Anybody else not have that graph?
I'm gonna say just because it's dark.
Yeah, I was talking to you just right over. You're dead. I'm laughing. Oh my God. But then since the air you weren't even doing anything. Indeed, that it was first thing.
That was in 7, 8, and 9. That's what it was. All right, everybody with us right here. Okay, so here's what we're finding here. This is how this relates to a graph. And I know y'all kind of freak out when we start talking about graphing stuff. But this graph, the zeros are the x-intercepts. What's it mean to be an x-intercept?
Go through the X.
Go through the x-axis. Okay, so we've got a number right here. What number does that look like it is?
1, -1.
-1. There's 2 more over here. What is it?
-4. No.
+4, +5, right? Okay, now, here's what we need. We just need one of those to start with. I'm just going to start with -1. I'm going to use it in synthetic division. And then I want to show you that you're going to get 4 and 5 with what's left over. Okay, what the quotient is. So I'm putting -1 up on the shelf there. And running that through with synthetic division. And I do get a remainder of 0. So that tells me that x equals -1 is a 0. Now here's what I had left over when I did my division. That's a quadratic. And we spent a good little while on solving quadratics. What are my options for solving that quadratic? The x method for factoring or quadratic formula, the x equals -b plus or minus radical, that stuff. That's either of those is an option to solve that. Okay.
I'm sorry, I just don't know.
All right. So this one factors, and since factoring is something we need to work on, multiply to be 20 had to be -9. That'd be -5 and -4. So it's x minus 5, x minus 4, and set each of those equal to 0. X equals 5, x equals 4. Where were those places that cross the x-axis at? 5 and 4. It's the same ones. We found the zeros of that polynomial. This one was nice in the fact that they were all rational zeros. That won't always be the case. Okay, so that's why I talked about quadratic formula there, because sometimes you can't factor it, and if you can't factor it, it's not going to be a rational zero. It would be irrational, meaning it's got a square root in it somewhere. Okay, so let's look at another one. Okay.
When you do the graph thing, are they always going to be
If they're rational, yes. Like I just said, they won't always be nice rational zeros.
Well, if they're not rational zeros, they're going to show on the graph.
They will show on the graph unless they're complex, which means you take the square root of a negative involved. They don't show on the graph. Real zeros show on the graph, so that means things that don't have a negative discriminant on the quadratic part. That shows on the graph, but complex ones don't show on the graph. So that's we'll see that as we're doing this the rest of the week. So
we all made a A in here. Would you get all our names tattooed on your back?
Absolutely not.
You know how painful that would be.
You know how dumb that would be? So here's our polynomial. Let's say we got x to the third minus 4x squared minus 15x plus 18. So I still want us to do the P over Q list, even though we know that about the graph, and that there are only going to be certain ones that work. I still want the whole P over Q list. So this one's nice. We got a leading coefficient of 1. So that means we're only going to have the factors of what? 18. What are the factors of 18?
1, 2, 3,
And 18. Plus or minus on all those. So 12 possible numbers that it could be. Next step is set up your synthetic. 1, -4, -15, 18. And then what are you going to do? Plug it in the calculator and graph it. See where it's crossing the x-axis. And I'm just going to clear out the other polynomial, x to the third minus 4x squared. Make sure you use a minus sign, not a negative sign. We had that problem. That's frustrating when that. After you've typed it in, yes, you hit graph. Let me make sure I put it in there right. Minus 15x plus 18. Yeah. No, you won't have to hit Zoom 6 every time. Once you hit it the first time, it stays the same. Yeah. All right, so we got a -3, we got a +1, and we got a +2, 3, 4, 5, 6. Pick one. I'm going to pick positive. That'll work. That'll be fine. Whichever one you pick, use it in synthetic division. So I'm gonna use the +1. Okay? Because it's positive and I don't have to deal with the negative signs as much. Run that through with synthetic. So I get a 0 as my remainder. That's what I expected to happen. Whether you used a 1, a -3, or a +6. Now, depending on if you used a -3 or a +6, you've got a different trinomial here at the bottom than I do. but you would still end up with the same answers at the end, because we have a trinomial x squared minus 3x minus 18 is equal to 0, and we can solve that either by factoring or quadratic formula. Doesn't matter which one, pick one. This one will do either. Yeah, if it'll factor through the x method. So negative 18 had to be negative 3, be negative 6 and 3. It'd be x minus 6, x plus 3. When you set those equal to 0, there's your x equals 6. There's your x equals negative 3. So your zeros are x equals 1, or I'm going to put them in numerical order, negative 3, 1, and 6. And you're probably thinking, oh, I can shortcut this and go through just look at the graph and get them all every time. No. Because if they're not rational, that doesn't work that way. Okay, so this is why you need to practice doing it when it does work, so that when we get to those that don't, we can do something about it. All right. Let's look at.
Is this all we're doing?
For right now, today, yes. Today, yes. And then we'll build on it as we go. All right, so let's look at example D. Let's go to a higher power polynomial. We've been finding cubics. Let's go to a fourth power, and we should have how many answers? Did we?
Yeah, we're on E.
We're on E. Thank you. All right, so let's go to a fourth power. How many answers should we have if it's fourth power? 4 at the end, okay? All right, so let's say we had g of x is equal to 9x to the third plus, it should be the fourth, sorry. 3x to the third minus 30x squared plus 6x plus 12. Twelve and 9, so the factors of 12. 1, 2, 3, 4, and the factors of 9. 1, 3, and 9. Okay. Now, one of the important parts of the P over Q list is the fact that if this thing doesn't cross at a nice spot, we're only going to have a certain group of fractions that it could be. So we're going to see when we graph this one, it doesn't cross on the x-axis at a nice spot in a couple of places. So we've got to think, okay, what fractions could that be? Is it possible that one of those works? Okay, so all of our factors here, we got 1, 2, 3, 4, 6, 12. And then that's the 1. And then we get into the fraction part. So 1/3, 2/3, 3 over 3 is 1. We already got that. 4/3. 6 over 3 is 2. I've already got that. 12 over 3 is 4. I've already got that. And then I'm going to run the 9. So that's 1/9, 2/9, 1/3, 4/9. Ran out of room there. 6 over 9 is 2/3. I've already got 2/3. 12 over 9 is 4/3. I've already got that. So there's my list, P over Q. Possible rational zeros for that polynomial. Obviously, if you can avoid using a fraction, you want to. So we're going to look for something that's not a fraction first and hopefully use that. So I'm going to set up my synthetic for this particular problem. Now what am I going to do? How? Yeah, type it in the calculator, graph it. See where it's crossing the x-axis. Let's get there first. Clear that one out. So 9x raised to the fourth. And then we have plus 3x cubed. And then minus 30x squared plus 6x plus 12. Make sure everything's right. Looks like it is. And I can hit graph. I'm looking for where that's crossing the x-axis. There's 1, 2, 3, 4 places. Okay. This one is in between 0 and -1, so that's a fraction. This one looks like -2. Is it -2?
Yeah.
Here's how we decide. When you're not sure, you can hit the trace button, which is the one right beside graph. Trace -2 and hit enter. And notice it gives me y equals 0. That tells me that that's going to work. Trace and then type in the number. That's when I was taking algebra when I was in high school, we had to take -2 and by hand plug it into the polynomial and decide if it worked out 0 or do it with synthetic division. And if it didn't work out with 0, you had to start over, pick another number. Okay, so that tells us that -2 works. That's not a fraction. That's a good number. So I'm going to go ahead and do synthetic with that. Yeah, really, sure. I don't know that we did. Easiest time of my life. I ran the -2 through with synthetic. I got a 0 remainder. That's what I expected to happen. That's what I wanted to happen. Now, here's what I want to do next. This is, what power is this now? To the third. It's not small enough for me to do quadratic formula with yet. So I want to run synthetic again if I can. So I want to do synthetic division on what's left here. So I'm going to go back to my graph and I'm going to try to find a number that works. On my graph, that's a fraction, so I'm going to try to avoid that. But this one looks like it's close to 1, right? I think it's right on it. I'm going to test it and see. So I'm going to hit trace, type in the number 1, hit enter. Hey, it works. That's good. That means we can use 1 in synthetic division. And I'm going to use it into the synthetic division of what's left over from the first time. Okay, that's breaking this polynomial down to where I can start doing the quadratic formula or factoring with my quadratic like I know how to do. All right. Bring the 9 down, run that through. -6. Now I have another remainder 0. What I expected to happen. I saw that happening on the graph. I've got a quadratic left over. 9x squared minus 6x minus 6. I'm going to set it equal to 0 and solve it. What can I do to make this easier for this problem? Divide by 3, because they're all divisible by 3. So divide by 3. No, because we're going to divide both sides of the equation by 3. We're going to divide this 0 by 3, so that keeps us from having to put it out in front. Because we're legally dividing everybody by 3. So that's going to get us 3x squared minus 2x minus 2 equals 0. And then I want to try to factor that if possible. So if I look at the x method, -6 on top, -2 on the bottom, is there anything that does that? Multiplies to be -6, adds to be -2. Nothing works. So that means I have to do it through what method? Quadratic formula. Or I could do complete in the square, but nobody wants to do that because it's not even easier. So remember quadratic formula, x equals negative b plus or minus radical b squared minus 4ac divided by 2a. All right, so plugging in the stuff that we know. We spent a lot of time on quadratics earlier in the year. So it'd be 2 plus or minus the square root of negative 2 squared minus 4 times 3 times negative 2 over 2 times 3. I'm going to work that out. 2 squared is 4, and then I have negative 12 times negative 2 is positive 24. So that'd be positive 28 inside of the radical and over 6. I've got to simplify that. And that's over, yeah, I finally showed up. Over 6. Now I want to simplify the radical 28. Remember doing the factor tree stuff? Pair of 2's. That's 2 plus or minus 2 radical 7 over 6. And then those 3 highlighted pieces are all divisible by what? 2. So divide them by 2. That should be a good thing. And
This is just a bunch of water.
that's the only reason we're doing it. Give you something to do. Keep you busy so you don't get in trouble. Yeah. That's right. All right, so let's get the decimal approximation for both of those. Now, what we want to see here is that the decimal approximation, we can look at the graph on the calculator and see, hey, well, that's actually where it's crossing the x-axis at. Because these are real solutions because there's not an I in there. So 1 minus the square root of 7. Get that answer. Divided by 3. Negative point. Let's go 3 decimal places. 0.549. And then that was this one down here, sorry. Did the minus first for no apparent reason. Let's do the plus side. 1 plus the square root of 7. Divide that by 3. 1.215. Now, if you look at the graph of that, and I trace that number, so if I trace negative 0.5, was it 549? That y value, not quite 0, but it's real close to it. You know, I rounded this at 3 decimal places. There was a whole bunch of other after that. If I use the exact value, then it's going to be 0 out of that. And if I do the positive side of that, the 1.215, I'll see that it's very close to that too. 1.215. Yeah, it's real close to 0, even closer on that one. It's just the rounding wasn't as far. We didn't round up, and then we stayed the same. So we get zeros of, what were the 2 easy ones? 1 and negative 2. Negative 2, negative or positive 1. And then we get 1 plus the square root of 7 over 3, and 1 minus the square root of 7 over 3. That's 4 zeros that we found out of that. You want to do synthetic until you get it to be a quadratic. So if it starts with a cube, you're only going to do synthetic one time. If it starts with the 4th power, you're going to do synthetic twice. If it starts with the 5th power, you do synthetic how many times? 3. It is that every time. Nothing really changes about that. Okay. All right, let's get a little practice the rest of the day today. I know it's kind of overwhelming a little bit sometimes to get a lot of this at once. So on page 374, let's do let's just start with 11 through 18. It says find all the real zeros, find every zero. Real ones are not. Okay? That's not bad. Okay, so that'll get you started. Tomorrow we'll work on this some more. And hopefully it starts making a little bit more sense by tomorrow. Or by the end of the day tomorrow. And maybe it helps you get better at the quadratic stuff that you struggled with before. Because you're going to use it. And you see that a lot with things that you struggled with before. When you start using it underneath something else, it gets a little easier. All right, so that's the plan for today.